So trigonometric identities is the next section we need to look at. It might not be immediately obvious as we look at these things why we're doing it at this stage, but identities for trigonometric functions, as we'll see, come in really handy when you're doing integrations in calculus in particular. So that's why this is covered now. So it's unlikely you're going to use these unless you carry on with your studies and start looking at integral calculus. But it's part of the syllabus, so that's why we're covering it now. It's basically what we're going to end up is with a series of little rules called identities that relate trigonometric functions to each other. So let's have a look at them some now, and basically we're going to end up with a list of these things. The first ones come about because of this idea. If you think about sine to the minus 1 of theta, in the past we've thought about x to the minus 1, something like that. If I write that down here, x to the minus 1 as meaning 1 over x. You might remember that from the laws of indices. Something to the power minus 1 means the inverse, 1 over it. But in trigonometry, sine to the minus 1 does not equal 1 over sine theta. Sine to the minus 1 something of theta on your calculator means the angle whose sine is theta. So if I'm given a number and I want to work out the angle whose sine is theta, I'd find sine to the minus 1 theta. So for example, on your calculator, if you worked out what sine to the minus 1 of 0.4 is on your calculator, what would you get? So sine to the minus 1, 0.4, 23.5 degrees. Let's just think about that for a minute in terms of what we've already been talking about. What that's saying is, if we look back at our wave function, the original one we had, this, your calculator works out what the angles are, this angle theta, assuming that this amplitude is 1. So it takes the standard circle with the unit amplitude. So this point here would be 1. And so what it's saying is, what we've just done on our calculator is said, right, what's the sine? What's the angle whose sine is 0.4? So in other words, 0.4 of the way up here, or 0.4 along here. Remember, oh, this is in out of position now, isn't it? So if it was here, 0.4 along here, in other words, 0.4 here. That angle, what is that angle? What is that angle there at 0.4? And it's told you, 23.5 degrees. If I put in the sine of 1.4, what would happen on the calculator? Try it. If we put sine 1.4, we get math error. Why? No. Why math error? Do you remember what I was just saying? It's telling me what the angle is as this rotates around the whole circle, assuming that this is 1. So what's the greatest this can be? So 1.4 cannot exist. It's got to be between 0 and 1. What is the angle whose sine is 1, by the way? 90 degrees, right. So if you in your calculator just finally inverse sine, the angle whose sine is 1 will give you 90 degrees. But the inverse sine then means the angle whose sine is, say, 0.4. So we need something else to represent 1 over sine, or 1 over cos, the inverse, or 1 over tan theta. And so the first things we need to understand about these new identities is that 1 over sine theta is equivalent to, that means it's defined, it's the same as the cosecant of theta, or cosec. So you may or may not have seen that word before. All it means is 1 over sine theta, and it's called cosec theta. So that's the first identity that we can write down. And then we have two more words, one for 1 over cos, secant, or sec theta, means 1 over the cosine of theta. And finally, 1 over the tangent of theta is cotangent of theta, or cot theta. So we have three new words, And those are our first identities, really. Cotangent of theta, or cot theta, is 1 over tan. Secant, or sec theta, is 1 over cos. Cosec theta is 1 over sine theta. So you can write those down as the first 3 identities that we might use. So on a separate piece of paper, you might want to make a note of those. So now what we're going to do is to use these 3 identities for cosec, sec, and cot, to give them their short names, and also sine, cosine, and tangent, what we mean by those, to try and come up with some other identities. And so we're going to think of them in terms of the right-angled triangle. And I'll stop this here, and then we'll carry on the next video clip.